Hello everyone. All right, well, I am gonna be doing some more. This is gonna be more algebra and trigonometry. I'm still setting up here, so just give me a second. Primarily, I'm trying to make sure that the stream is working properly. As you can see, I'm using a different setup now. I've tried to simplify it a little bit and make it so that, there we go, streaming. And I tried to make it so that I can run this thing. What happened was that I was using StreamYard, but I've streamed almost 20 hours worth, and that's the limit per month. So I was either going to have to pay the $200 or I had to do something else, and I chose something else. I've used Open Broadcasting System, OBS, before, so I know how to use it, and it's great. I like this new setup. I made a slightly different banner, and yeah, let's get into it. Okay, and let me see here. There we go. Okay. We are in 1.2. All right, so the book we're working with, this is Algebra and Trigonometry. It's part of OpenStax, which is part of the Creative Commons. The link is in the video description. I actually have a physical copy. The physical copy is really nice. And you can get yourself a physical copy, but feel free to download it right now so that you can see what I'm doing and if I am getting the right direction. Because you can check the answers in the back of the book. You'll know before I do if I'm getting it right or not. And the usual rules apply. I am going to be doing the questions, but I'm only doing the odds. I'm not doing any of the evens because the evens are used for teaching, so I don't want to damage the integrity of the book. We are carrying on from, let's see here, I think the last one we did the algebraic. Yep. We are at 45. Okay. This is carrying on. So this is real world applications part, 45. A dime is the thinnest coin in U.S. currency. A dime's thickness measures... Okay, so I'm just going to write the relevant stuff. By 10 to the 6 meters. Wouldn't that be... What? What? I think they wrote this wrong. It will be the 10 to the negative 6 meters. Rewrite the number in standard notation. Okay, yeah, I think that's an error in the book, actually. This is how it's written. Okay, so if this was it, it would say that the thickness would be like it would be like 2,200,000 meters. So we know that's not it. Right, so I'm just gonna write this the way I see it. Hang on a minute. I see what they did there. I think the mistake came from question 44. They also had a 2.2 times 10 to the 6 feet per minute. But that's a rocket velocity. So that actually makes more sense. The escape velocity sounds about right. I think they meant to say this in the book. So yeah, I'm pretty sure that's an error. I mean, it wouldn't make any sense otherwise. So let's just roll with that. The way you do this, you go like this, 2.2, and we're going to go 10 times 10, so we're going to go 6 times. 1, 2, 3, 4, 5, 6. Okay, so dime's thickness measures me. Yeah, right. Okay, let's roll with that. See if the book's okay with that. I don't know. It seems that's too thin, but because then you have I don't know what they're trying to say with this here. When I'm going to look it up, we're going to know very quickly. Okay, that's how it would be in standard notation. Let's check the answer. I think there's some kind of a mix-up here because it's exactly the same as the velocity, except they just... Hang on a minute. I'm getting my stuff off the desk. Okay, so I'm checking the answer in the back of the book. Let's see what they say here. All right. 1.2. Odd answers. Here we go. 1.2. There's some kind of a misprint. Yeah, because this isn't right. The thing they wrote in the back. Okay, if you have a copy of the book, look at question 44 and look at question 45. Both the 2.2 times 10 to the 6 feet per minute is the escape velocity, which sounds about right. 45 is 2.2 times 10 to the 6 meters. I think what they meant to say, here's what we're going to do. We're going to look at the answer, and we're going to do the opposite. In other words, I'm going to, since... yeah, I'll show you what I'm saying here. What they're saying, this is basically scientific notation. And here is, like I said, that looked too thin to me. So, and it can't be the opposite. Definitely can't be. So, this is what it says in the book. So, that's standard notation. Why don't we just take this and rewrite this in scientific notation? So, we're going to go, let's write this down here. 1, 3, 5. You just get to the first 1, 2, 3. So it's going to be 1.35 times 10 to the negative 3. Okay? So then, yeah. Because then, to get back into it, we're going to go 1, 2, 3. We're going to go 1, 2, 3, like that. Okay? So that's, and then we're going to write meters. So that should be, we're basically reversing what they did there. They started with this question and they wanted us to give them that. But the way the book has it written, it wrote the incorrect thing, which, again, I can clearly tell whoever was typing this up just looked at, they were just rolling through it. And then they just typed in 44, and then they rolled into the next 45. Probably didn't have their coffee or something. I don't know. It happens. All right. Let's keep rolling. $47. Okay. A terabyte. I'm sorry. Everybody's sick right now. I've had this for about, I guess, month and a half. It's not going to go away anytime soon, I guess. I've gotten better, but this is, whatever it is, it's just, I'm not going to wait till my cough goes away. I work every day, 8 to 10 hours. Just like today. Today was an 8-hour day. And then just a lot of leaf cleaning in the rain. Fun times, but I'm fully prepared for. And then afterwards, I did some interior work. I was putting up some curtain rods. Anyway, so yeah, a pretty good day. But anyway, like I said, I enjoy what I do. I enjoy making a difference for my community. So this is gonna be bytes. So we want to rewrite in scientific notation. All right. So let's go here. We're gonna go 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to say 1 point. That's a good question. What about rounding? Let me see here. Hold on. I think of 2 significant digits backwards. That's a good question. In terms of rounding. Here we go. Rounding figures to 2 decimal places and find the amount per citizen. Okay. So yeah, for scientific notation, we usually round to 2 digits, I guess. They don't specify in the rounding here, but yeah, it would let's just round it to 2 figures. And then if the book gives us something, hang on a minute. Oh, hold on. Here's 1 to 3. Okay, I'm just looking at the examples. All right, you know what? So if it's to see, here's kind of the trick. If we were to round it, then we would basically end up with 1.1 times 10 to the, what is it, 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So it's either going to be 1.1 times 10 to the 12, or it's going to be 1.0995 times 10 to the 12th. It's going to be one of the two. All right. Just a question of how they want it rounded. All right, let's see here. 1.2. Okay, so yeah, they did not want it rounded. So this was the correct one right here. Okay? And here's the thing, like if they don't tell you what it has to be rounded to, then I could have written both answers and said if rounded, I could say or if rounded, or this is say unrounded, whatever. But I mean, it's fine. Primarily, here is just demonstrating scientific notation, and whenever you actually deal with it, like in a physics class, which I did not pass, by the way, another thing that I dropped in order to focus on work. So what happens is the professor will tell you what the significant digits is. So, like 2 or 3 significant digits or whatnot. And then you have to, all your work has to be done within that. But you also, you have to be careful because you can't round from one time to another because every iteration, if you keep rounding, you're shaving off those little bits. And that could end up to a lot of shavings. So generally you round at the end, but you got to talk to your professor. I'm just a landscaper/handyman who goes to a university. I am not a teacher. Anyway, let's keep rolling along here. All right, here we go. All right, paint bucket. All right, picometer is approximately 3.397 times 10 to the negative 11 inches. Rewrite it using standard notation, okay? By the way, this whole, this little 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I learned that in like middle school or something like that. I don't remember where we were taught that, but it's a really handy thing, Usually, if you screw up on this, it's because you made a silly mistake somewhere. Except I went the wrong way. Number of zeros is correct, but actually, you know what? This is gonna look completely insane, but yeah. Well, why don't we do something crazy here? Okay, obviously this is not how you do things, but okay, we can just do that. Anyway, that's because I made a mistake. This isn't actual technique, okay? So just don't think of this as some kind of this weird technique. So let's just count this here. Okay, let's just do this one more time. Hang on a minute. It just didn't feel like rewriting the whole thing. Okay, so it's, yeah, because if it's negative, it's going to the left. If it's positive, it's going to the right. It's different, just like a number line. Think just like a number line. So we're going to have 1, and add a 0 here for convenience. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. Check it again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So that should be the answer. 3, 4, 5, 6, 7, 8, 9, 10, 11, 9, 7. Okay. That's the answer. Inches. All right. Standard notation. Check it. And this is number 49. It looks right. Hang on a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, let's see here how many zeros. 1, 2, 3, 4. 4, 5. It's very hard to count these. Let me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Should be 10 zeros. Let me just count this one more time here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and perfect, 11. All right, that's the correct answer. Book agrees. All right, that's good. And okay, so we have some radical. I'm already looking at the next chapter. Okay, now it's some technology. 51. For following exercises, use a graphing calculator to simplify. 12 times 3 meters. 33. I'm just gonna do it by hand. Why not? Okay, so then we're gonna say, so the squared means 12 times 12 is 144. And hold up. Okay, no. Okay, I see what they're saying. Okay, because it's not correct. PEMDAS, remember PEMDAS? Parenthesis is the first thing. Anything that happens, even if it's just 1 minus 2 or whatever, the parenthesis comes before exponents. So we need 12 to the third power. Okay, so that's going to be, so the first action we do is we do the stuff in the parenthesis. So 12 times 12 times 12 is 1728. And then m is to the 33rd power. That hasn't changed. You know what we could also do? We can take, I don't know, we'll do one at a time. This is a tricky one. I see what they did there. So 4 to the negative 3 is going to be, we'll do this in a minute. I want to flip it. I'll show you what I mean. So they have 1728. And then we have times 4 to the third power times m to the 33rd power. Okay, over 1. Actually, we don't need that. Okay, that's fine. Squared. Okay? Now, what we got to do is take care of the 4 to the third power. That should be 64. If my memory serves me, that's 64. So now we have 1728 times 64 times m to the 33rd power squared. Okay, now we have 1728 times 64, and that's going to be 110592 times m to the 33rd power squared. Okay, and now we can finally do this. Square this. Oh my goodness. Another big number. Okay. 1, 2, 2, 3, 0, 5, 9, 0, 4, 6, 4, 66. I believe that's the correct answer. Yeah. Whenever a number grows this big, I mean, granted, big is very relative in math, right? This is about the distance between 0 and 1 when you're talking like infinity or infinite sets, right? Even a number this big is just infinitesimal compared to how big numbers get. But, you can have numbers with billions and trillions and quadrillions of digits, and that is about as close as between 0 and 1 as it is from 0 to infinity, because it's just infinity is, it's very hard to imagine just how huge this is. 51. 1, 2, 2, 3, 0, 5, 9, 0, 4, 6, 4, m to the 66 power. Yep. All right, answer is correct. Alrighty, now we're going to do some extensions. All right, let's see what we have here. Okay. Ready. So. All right. I'm going to say, whoop. Okay. So now we are in 53. And extensions we have 3 squared over a to the third power times negative 2 power times a to the fourth power squared times 2 squared. Okay, so right away, let's just get the parentheses out of the way. Get the stuff inside of them. Now this is, okay, so we have 9 over a to the third power. And then we have to the negative 2. Okay? So, you know what? Let's just be brave here. I have a better idea. Why don't we do this? We're going to say 9. This is a 9. And this is going to be a to the negative 3 to the negative 2. Okay. So then, and we're going to multiply this by a to the fourth power times 4 times, and it's going to be squared. So now, what we have here is, I'm going to take the negative second power. So we're going to take the 9, and we're going to have, it's going to be 1 over 81. So it's going to be 9 times 9, or 9 squared, but we drop it in the lower case. So it's going to be 81, 1 over 81, and then we have, the negatives cancels out. 2 times 3 is 6, so it's going to be a to the 6th power. Okay, and then we have, now I'm just gonna, actually not, let's just go like this. A, so be our a to the 6th power, okay? All right, and then we have a to the 8th power times 16. Okay, and then we'll just put this over 1 because the other one's in a fraction. When you have fractions, it's easier to do that. So then we have 16 over 81, and then we have a 14. I believe that's correct. Now, can we simplify it? So for the 16, we have 2s and 4s in there, and 8s, and 16. 81 is going to be, we have 9, 3, and yeah, no, none of the numbers, we can simplify it. Okay, so that should be the answer. Let me check. All right. I got something wrong here. Hold on. So it says A14 over 1296. Okay, so I did something wrong. Let me see here. Let me see. Hang on. Maybe I wrote the question wrong. Let me take a look here. Oh, okay. So I solved it correctly, but oh yeah, that's no. I wrote it wrong, and that's where I made the mistake. Okay, well, let's just fix it. It's right here. Okay, so let's just fix that. Nope. Why am I still using this? Okay, so then we have 2 squared. There we go. Okay, that's a little better, and then we're going to fix that. Okay, and this is going to be... So I should have just checked my work. Check your work twice, submit it once. Okay, So that's going to make a little bit more sense. Now, 81 times 16 should be 1296. At this point, that's just a hunch. I have to check it. Yeah, it's 1296. All right, 1296. Okay, good. So this is what the calculator is really for. It's not for putting in the whole equation and then having it spit it out for you. I mean, you could always do that, but we don't want to do that, right? We want to be able to work this out as much as we can so that we're familiar with it. But for multiplying large numbers, then, that's just like a shorthand. You could sit there and do it by hand, but it's just, we know how to do basic multiplications at this point. All right. Okay. 55 m squared times n. That's a nice looking n. To the negative 2. No, sorry. There we go. All right. Now I'm going to check I'm going to write it out first. I'm not going to fixate on it too much, but I want to go back and take a good look, make sure I'm not writing silly mistakes and then paying for it. All right. And m. All right. And m squared and c4. Okay. All right. All right. Well, what we can do right away is that I want to start. See, like my temptation is to start crossing ones out, but let's just put everything in their place. Let me just think about how I want to do this. What's the best way? Well, you know what? All right, we're going to go like this. We're going to get rid of the negatives right now. Let's just start with that. M squared n to the third power. Yeah. And then over a squared and c to the third power times c to the fourth power over a to the seventh m squared and n squared. Okay, let's make sure I did that part right. Just looking at the book. Yes, this looks right. Yep. I'm just looking at the way it's written here. And then based on how that goes, we'll see what I do next. Because the first thing I got to do is make sure that I put them in their right locations. Get rid of the negatives, right? All right, I think that's good. Now, what we can do then is this. Well, we can scratch these two. We don't want them anymore. All right, and then we are going to say, well, we can start solving this. So this is going to be 1, and this is 0. And then the rest we're just going to multiply. So we're going to say c to the 7th power over a to the 9th power. And then we're going to say n times c to the 7th power. So n to the first power is just n. N to the 0th power is 0. Or is 1, sorry. N to the first power, it makes it n, or any other number really. And anything to the 0th power, it makes it a 1. 1 times anything returns you back that number. So we're not going to worry about the 1. Just keep that in mind. This says this equals to 1. Okay. All right, and then we have a to the 9th. Good. C to the 7th, and good. I think that's right. I think that's all we have here. Let me double check it. Got rid of the m's, a's combined, c's combined, And now remember, it's when you multiply and you have two exponents, you simply add the exponents. But if you have an exponent to and another exponent, so let's say 4 parenthesis to the power of 2, then you multiply the 4 times 2, essentially. So that's when you do multiplication. But yeah, if it's just a multiplication, then it's addition when it comes to exponents. You add exponents when the variables that we're using, like a, b, or c, or n, whatever, when we're multiplying that by other similar variables of its type, meaning c times c, or n times n, m times n, whatever, and then that's your add. But when you go to an exponent, say, like I said, c to the 4th power, and you square that out to the 3rd power, you multiply the inner part of the parenthesis by the outer part. Remember, you do all the functions within the parenthesis first, PEMDAS. Remember PEMDAS. Parenthesis, exponents, multiplication, division, addition, subtraction. That's the order of operations. Okay, let's go check it out, see what the book says. Make sure I didn't make any silly mistakes here. Now, when I say a silly mistake, I'll explain that in a second. First, I want to check this. Section 1.2. And... I did make a mistake. The C was wrong. Did I write the C incorrectly? Okay. Wait a minute. Why did I do that? I moved the C to the top. Yeah, that's like I said, this was a mistake. I'll correct this. But here's what I'm going to do. I'm just going to write this as a negative. Because I moved it to the top for no real reason. And then, so we're going to... Okay, sorry. It's just late in the day. My brain's not fully working here. That's a silly mistake, right? A serious mistake, or not a serious, a mistake, I would say, versus a silly mistake, is that where you don't understand the process. Where you understand the process, but you made an error in terms of, like, you wrote something and that's negative as a positive. And, this is just, like, for homework kind of stuff. It's considered, obviously, if it's a test or, you're working somewhere, that's a pretty serious mistake. That's the kind that causes satellites to crash into Mars and whatnot. But let's see here. So that, yeah, so then we put the C up top. That's good. And, yep, okay, that's the correct answer now. It's been corrected. All right. Let's go to 57. And, wait a minute. I just want to look at 59, see if I want to open up another page. Planck's constant is an important unit. Yep. Describes our energy and frequency. Oh, no. All right, okay. This is going to be fun. I'll leave the bottom row for the last question. Yeah, okay, let's do that. I'm going to need room to write. I'm going to need... Actually, let's see here. All right, I'm going to try and solve 57 in here. 57 in here. Let's try to do that. Okay. A, B squared. C. Okay. B to the negative 3rd power. And squared. Okay. All right. Well, let's take a look real quick here. All right. Well, let's just do this. I'm going to start solving them. So B to the 3rd power. And then we're going to say A to the 3rd power. I'm just getting rid of negatives. B to the negative 6. B to the 6 now, since we're putting it in the bottom. And C to the 3rd power squared. Okay? So then, now we're going to say we're losing the B. 1 over A to the 3rd power. B to the 3rd power, C to the 3rd power. Okay. Squared. Okay. All right. Okay. I'm gonna finish it now, and then do they? Let me see here. They don't say. Okay, right answers with positive exponents. Okay, so then in that case they want it in fraction. So we're gonna say a to the 6th, b to the to the 6th. That's right. Wait a minute. Yeah, it's what I was saying. Yeah, when you have exponents, you multiply. So this is what I was saying. You're gonna multiply the exponents. So it's 2 times 3, not 3 squared. And b to the 6th, c to the 6th. Okay. All right, let's check that. Make sure we summon the beast correctly. All right. That's right. We just summoned Satan. Perfect. All right. Book agrees. I told you math was magic. And magic is heresy. All right, so here we go. Planck's constant. 6, 2, 6, 0, 6, 9, 5, 7 times 10. Negative 30. You see where this is going, don't you? Oh my God. Here we go. Let me check it again. Let's see here. Okay. Yes. Yeah. This is why this. Oh no. Okay. Write this in standard form. Okay. One more time. Okay. We're gonna go 6 point. It's gonna be a long row. Okay. Let's see here. 6.62606957. Okay, let me check it again. 6.62606957. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is 10. 11, 12, 13, 14, 15. Wait a minute. Okay. Right. Glad I caught that. See, I write things at a slant, which makes moving things incredibly annoyingly hard. There we go. Okay. Okay. All right. So here we go. 34. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. So 9 zeros because I'm 1 past 6. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. There's Planck's constant. Okay. So what I'm gonna do is I'm not gonna bother erasing that whole hang on a minute. There we go. Okay. Yeah, we get the idea. This is how you do it. Okay. Yeah, we understand. All right. Yeah, it's a long string of numbers. I'm not gonna bother counting them. Okay. Yeah, that's how Planck's constant works. Okay, good. Well, that's it for this chapter, and yeah, that was kind of fun. I like all the little things that they stick in there that troll with students and whatnot. It's fun. Okay. Well, let's see here. I am gonna do a new stream after this stream. So I'm going to end this one because the chapter is now over. Thank you for coming today, and I'll see you next time.